This is a very short talk. I'll try to keep it short. It's about the build system design for ARM platforms, which has been around for a long time in DPDK build subsystem for ARM. But we did some changes recently, and maybe there are some confusions, and trying to explain the design philosophy behind those choices. So. My name is Wathsala. I'm a software engineer at ARM. And as you can see from the names, Honappa was also involved in this change. The motivation for this change was actually based on the fact that ARM is fairly diverse in terms of ISA versions, architectural extensions. If you look at the Meson build file for ARM, you would see these ISA versions and extensions used widely by different SOCs. And then to make matters even more complicated, we have different kinds of vendors. Some are interested in highly performant builds, and some may not be that interested in the performance. They may try to make it more portable, like, for instance, distro vendors. So, as I mentioned, these highly performant builds, which are preferred by SOC vendors and appliance vendors, kind of tuned for a very specific ISA version, and they may also have a set of architectural features that they may want to use with that build. And on the opposite end of that spectrum, you will find the portable builds. People who value the portability, they might want to have some kind of a good out-of-the-box experience of a particular build. So they may focus on the portability. Mostly Linux distro people, they are the ones who are kind of interested in this approach, right? And then we have three kinds of builds that we try to push to address the different crowds, right? So the first one would be the generic one, which is kind of very simple. It's for portability. And you can also fall back to generic if the GCC version that you are using or DPDK lacks support for a particular CPU, you can fall back to generic. It's pretty simple. You pass dplatform equals generic at the build time, and then it will generate like that argument will get translated into mark equals ARM v8a plus SIMD, which means generate a binary which works on any ARM v8a and below plus some Neon extensions. So this is the most portable one. Any 64-bit ARM CPU out there would understand this instruction set, whatever that goes into that binary. And the next one is SOC specific. Why we need this? It's because we care about, some people care about performance, as I mentioned. If you are a SOC vendor or a appliance vendor, might want to have some performance benchmarks out of that build, and then in that case you will want to build it against a particular SOC. So the caveat here is that it should be supported by the version of GCC you are using, because we are relying on the MCPU flag. So for instance, if the GCC version that you are using does not recognize that particular MCPU or the CPU name, it will fail. So that support needs to be there, and also DPDK's ARM build subsystem should understand that argument. So for instance, in this case, I'm using V2 as an example. So if you pass D platform equals V2, that's going to build a binary that works on Neover's V2 line of CPUs, right? And then we have the custom builds, which are kind of in between, I would say, because there might be folks who need performance, but at the same time, the GCC, the latest GCC version may not recognize that particular CPU. For instance, like up until GCC 15, the V3 and N3 CPUs were not recognized in MCPU argument. So we had to use this custom build option. So here, what you're going to do is in the Meson.build, you have to define a MCPU version, which is basically made up of, we call it a pseudo MCPU. You can call it a pseudo MCPU. I'll show you how one could generate this. So you can specify the base ISA version, and then the set of extension that you want to use, and call it, let's say, foo, and you pass D platform equals foo into this build, and ultimately the build system will generate mmark equals the ISA version you gave plus the list of extensions. So that way you don't use the MCPU, but as the person like who's basically as an expert, you may know the ISA version and everything that particular CPU supports. So this is actually how you add a SOC specific build to the Meson.build. So let's, for the time being, ignore the box 0 and focus on box 1. I'm using NVIDIA Grace as an example for this. So you start by defining a SOC. Now SOC Grace has a part number, which is a hexadecimal value, D for F. And this part number is unique to Neover's V2 CPU model, right? So then it refers to a part number definition in the part number config space, and it says that MCPU that you're supposed to use with this particular build is Neover's V2. And then these flags, you can ignore these. These will be passed into the build as macros. But it also specifies some extra features, some features that are unique to this particular SOC, in this case Grace. It is crypto, right? So once you have this definition, you have to give it a short name. You add that to the SOC's dictionary, and the name is Grace, and it refers to the SOC Grace definition. And then in the build time, you pass the parameter D platform equals Grace, and then the build would generate this MCPU, the red box, in the build time and pass this to GCC. So what's going to happen now is that the binary will use the ideal ISA version for Neoverse V2 with the crypto extensions, right? So it's confusing because it's a little bit different from x86 Intel definition of MCPUs, MTune, and all these other things. So ARM uses a different convention, I guess. Now, if you want to do a custom build example, it's almost the same. Let's look at the box number 2. In this case, it's I think Thunderx 2. It does not have an MCPU defined, so we'll have to add a custom build SOC. So you define the SOC. Part number for that particular CPU is here, which is hex AF, which is referred in that line, and then you have the definition in the part number config. Now, if you look at this, this MCPU, it does not really exist. So it is a like a pseudo MCPU which you define much later in that MCPU defs direct dictionary, right? So if you look at the MCPU defs dictionary, it defines MCPU underscore ThunderX2T99, which I think Marvel knows what ISA version it supports. So according to them, it's V8.1a, and it has a bunch of extensions, CRC and crypto. So ultimately, when you pass this argument, dplatform equal ThunderX2, it's going to generate that mark. Since it does not have an MCPU defined in GCC, it generates that mark equals ISA version plus CRC plus crypto, which is the optimal binary for that platform. So we have a couple of these things. So there's one caveat here. The moment a GCC compiler version starts supporting this CPU, then you have to remove this content in box 0 and use the proper MCPU. So you don't have the custom definitions, like kind of no use of it after that, right? Yeah, that's it about the build. With that, we'll move on to questions and answers. Not there.
Related question. Suppose I use a specific, build architecture, right? And how do I verify it? Is there any ARM tool to verify ARM perf tool or something that will tell me that it's running better?
You mean verify means you have the binary and you want to make sure that it supports a particular.
Yeah, I compiled with certain architecture, right? And I have to run a tool, and I can see that okay, this one performed better, or is it just that in the code there are specific machine architecture in a specific code that changes the binary itself?
Yes.
But I want to see the difference, right? How do I verify the difference?
So a lot of times the ISA versions, the difference between the ISA versions is the instructions. So let's say V8 has a set of instructions and V9 has all the instructions that were in V8 plus some extra instructions. So those extra instructions could be like SVE, SVE2, all the advanced SIMD instructions, and there are a bunch of other things like now we saw some RISC-V wait for event kind of things. So all those things we have in ARM as well in V9, but in V8 you may not find those things. So one way to verify is that, for instance, you want to use wait for event with a timeout. That instruction is only available in ARM V9 ISA, right? So if you build DPDK for that particular SOC, some SOC that uses V9, then it will emit those instructions in your binary. If you do an object dump, or the binary, you would see those instructions. But if you build it for some other ISA version, that instruction will be not there. It will be replaced by something else. It's like that. So there's no tool per se, but you can manually do the verification with a tool like object dump, which comes with the GCC, I guess. Does that answer the question?
There's some that's code that's not with binaries, it comes from open source, right?
Yeah.
Basically, some cases using some specific instructions that have a different flavor, different path, different
Yeah.
right? So I'm aware of it, so I just want to looking at the report, right? So in the case.
Yeah, typically if you ask the compiler to use a particular instruction set version, it's going to enable those things. So, yeah.
Hi.
Yeah, we have perf. Like it's it's basically the performance counters. They also change from one CPU to another, right? Say, for instance, N1 may not have all the counters that are available in N3, and then we also have other counters which are off core on the interconnect. So you can use perf to measure all those things.
I don't have a question with respect to the ARM architecture per se, but in a DPDK, whole DPDK build system wise, to the DPDK maintainers actually. The point is that right now in DPDK, the build system is compile time, so you expect that the application will always compile the DPDK, but there are some open source projects which compile the source code for multiple architectures and runtime select it. VPP does it. It's a multi-arc select feature, and it is needed when the DPDK is being released to the distros and the application is linking to the distros, right? So at the runtime when the shared object is being loaded, the correct architecture-based compilation binary is being selected. The functions are being selected. So is there a roadmap for that? Because I was talking about it to Jaren and he said DPDK does not support it.
Yeah, right now we don't have anything, and I don't think there's anything in the roadmap either. For distros, like for instance, it's a generic build at this point. So if you do a 64-bit distro, then it's the dplatform equals generic. It will generate the V8 instructions.
Okay, cool. Good discussion, and maybe a breakout session this afternoon. Over to Nitin to give us a talk on RT graph.